Alright, look, check this out. The last problem I'm going to do, not the last problem, the second to last. I'm going to do generate parentheses after this. It's called combinations. Now, we did a problem called permutations, right? And I think here we're looking for, given two integers n and k, return all possible combinations of k numbers chosen from the range 1 to n. Can you do this? I never thought about it. Are you allowed to do this? Like, say length is n, and like pass in like index or something, and then like have index like increment, and then no, you can't do that, right? And say like let index equals 0 or some shit. Let me see. Can you do that? Just kind of curious. I don't really know. Sorry. Possible numbers. I'm just. This is just out of curiosity. Not a number, huh? Okay, but what if I did that? And instead, so like that, yeah. Yeah, that would work, right? Interesting. I think it's like start. And then start. I just developed a new way, not new, well, new for me in terms of how to create an array with numbers counting up, like just really quickly. So that's cool. I don't know, does array from have like, array.from probably has some way to do it, right? Like, you know. Interesting. Takes in a start, stop, step. Says that the length is equal to start minus, or stop minus start, so 4 divided by step plus 1. Interesting. So like 5. Okay, I guess that makes sense. Sure. That's what I'm saying. I kind of had a feeling. I was like, man, if there was like a way to do something like that, I feel like for example, let's look at it now. Oh fuck, I forgot to return it. Subscribe. Okay, low key, that's what I thought. And then if I did this, is that legal? Actually, no, sorry. If I did wrong place, that's definitely legal. It should give me the same shit. 1, 2, 3. Okay, sure, interesting. That is new. Not gonna lie, that is new. I had a feeling there had to have been a way to create a range easily, like you can in Python or something. Anyways, so we have these numbers. I assume the expectation is that we're dealing with positive numbers here. Yeah, so from range 1 to n. I It's not that we have to be dealing with positive numbers. It's just I just need to be aware of the range that we're talking about specifically. It's important to recognize that combinations are different from permutations. Permutations, order does matter, so these two are different. Combinations, order does not matter, so these two are literally the exact same. The combinations is like, do we have a 1 and do we have a 2? Doesn't matter where they are. Permutations is like, okay, well 1, 2 is different than 2, 1. Like, you know, so that's important. So that means once I'm done exhausting a 1, I want to start collecting combinations from 2, looking at 2, 3, 4. Like, I don't want to go back and look at 1. I will do that if it was permutations. But for combinations, if I go up, then that's it. Like, if I go up to 3, now starting at 3, I don't want to look back at 2, 1. I don't want to put 3, 1 there. 3, 1 already exists. So I think I like, in terms of, do I understand that part? Sure. This is these are our potential choices, and we've mentally defined our constraints. Define constraints of I moving forward and not including prefix elements. And then really all we have to do is just move forward towards our goal. Another constraint is length k. So I'm going to call a function called traverse, right? I'm going to call traverse is less than possible numbers dot. You don't even have to do that. It's less than n. I plus plus. We're going to call traverse, telling us to start from I. Telling us that what else might we need? Maybe current combination, perhaps. Current combination, and this sort of presents itself as a backtracking problem in the sense that if I have 1 and then I recurse on that 1, my options then are technically are to add for example, if k was equal to 3, then I could add 1, 1, 2 as a potential combination. And I can add 1, 1, 1. So I think actually we want to keep recursing on 1, really, until that reaches some sort of base case, which is if current combination dot length is equal to k, let's add it to our result. I think that'll work. So you know, okay, let's add it, current combination, to our result, and then return. And then we're gonna have this sort of thing. So we're gonna start from the start until end, right? So we're gonna go ahead and add the element. So we're gonna do current combination dot push possible numbers I. So we're gonna keep pushing and then we're gonna call traverse starting at I, right? And pushing that current combination. So the reason why this is important, so like if we have 3, right, what we're gonna do is we're going to add 1, right, and then so we push possible numbers accessing, so index 0 accessing that 1, we push that in there, we call traverse again, we push another 1 in there, we call traverse again, we push another 1 in there until our current combination length is equal to k, our maximum. Then when it is, we add to our current combination, and then we return. So when we return back to our previous scope, which would be from here. And then what we want to do is do current combination dot pop to remove that 1, and then go over, recurse again, or sorry, not recurse, we'll iterate. Now we're looking at index 1, which refers to 2, and then from 2 we push the element at index 1, which is that 2. We call traverse, right? I think it'll continue that going forward. Yo!
I'm out, bro.
All right, catch you later.
See you later.
Sounds good. I think if we add that 2 and then traverse recurrent combination, we're going to end up adding this to our output. So then we end up having like 1, 1, 1, and end up having 1, 1, 2, right? But then let's remember our current combination right now is 1, 1, 2, right? This is res really, and this is current combination to be exact. And then so it reaches the length. So then we go back to the previous scope and then pop, and then we're gonna go ahead and do the same thing with 3. So you hit, and then we see this same sort of pattern repeat until we do it with essentially everything, and then we come back and we pop we pop that 4, right? And then so how do I make sure to also look at the next element? I guess that's sort of the trickery here in the sense. Well, I mean, I think we'll actually do that though. We'll actually do that because then I'm gonna pop, and then I'm gonna return from this scope back to the previous scope, right? When I pushed a freaking the second 1, right? So when I put the second 1, so then I'm gonna pop. So I'm gonna take the 1 here, and I'm gonna pop that, and I'm actually gonna push 2, and then recurse again and push 1 and do the same process over and over again. This is when recursion, this is when recursion gets real fuzzy, man. This is when it starts, but, and I think it'll do more of that until this is, so we pop, and then we pop again, and we'll do the same thing with 3, and we'll add all of those. I think that'll work. I think let's give it a shot. If it doesn't, we can just sort of look at where we're at. Let's look at our output and see what we can do from there. I actually think it's possible that we even need to put this in a loop? Like, is this even necessary? Because if we have it starting from 0, it'll sort of handle all of that for us, right? It'll literally start at 0 and then start pushing 1 and then call it again and push 1 and then call again and then push 1 and then call again and push 1 until we add, and then pop from the call stack and then pop the 1, so we're at 1, 1, 1, and then it'll push the next number 1, 1, 1, 2, and then do the same thing, and then pop, and then put 1, 1, 1, 3. So I think it'll handle that. I don't think we need to put that in a for loop. I think this will be fine. This pop is like our backtracking element. The only thing is, so it didn't. So it's not working the way that I thought it would. But it is adding some. So it's 1, 2, 3, 4, 5. This is adding a little too much. But hang on a second. I'm calling I should end up incrementing on its own, really. And we're pushing possible numbers. So okay, so we start at 0 and do that. So push current combination. Push current combination. What if we did? Let me just see what happens if we do that. I'm just curious. If not, let's console log our. So so there we go. Okay. All right, so we have 1 1 1 2. It doesn't want us to include, so it wants us to unique combination. What, we can't include 1 1? I'm confused. Why is that? So we have our you know. I'm actually confused as to why you wouldn't include 1 1 as a possible combination. Let me get a drink of water real quick. I'm a bit confused on that. But I see. If it's going to be like that, then we should probably do traverse, and then do something like that where we start the combination off from possible numbers I, if it's gonna be like that, and so you know, we access at index 0, we get that 1 and we push that as a current combination, and then so when we actually push the current combination, we're pushing to that 1, but we're starting from I plus 1. That might be able to help out a little bit. I don't know. Yeah, so okay. All right, so let's check the other cases, or this case with a 1. Okay, so it works with a 1. What's another case we can try? I mean, the case we were thinking about before, right? When we have 4. And let's see if that works. So it gets wrong answer. Okay. Where did we screw up? Where did we screw up? I was expecting just 1, 2, 3, 4. This doesn't really make any sense. Possible combinations. Do these need to be unique or something? Like I'm very confused. Do they need to be unique? We can do this. Can I get to the yes? Sweet, yeah. Let's try pushing I plus 1. But why though? Why? You're just pushing I, but is I, is that not a unique combination? Like I'm actually confused. And is this gonna work? Oh fuck yeah, it works. Not only does it work, it works quick. Okay. Sweet, Chuck, nice. But I'm still kind of iffy about that. But anyways, that marks our 136th LeetCode problem. We're on the way up, guys. We're actually on the way up, I promise. Oh, I don't think I changed my resolution. You guys probably didn't even see that, huh? Wait, hang on. No. I swear to God. No, not combination of sum. Although I could probably get to it from here. Combinations. No. You guys couldn't see it, huh? No! Wait. Here we go. This was the output. The only thing I was doing here was checking the output, really. This is the code. And yeah, we have a sort of recursive depth first search like backtracking solution where after we're done reaching, or after we reach our goal, we're gonna pop and backtrack to a previous decision that we can advance from and get more solutions, and we cut off paths of our decision tree that won't lead to a proper solution. But damn, you guys could, well, I mean, this is it. You guys see it, and I'm gonna assume that people also had similar solutions. Yeah, I mean, so they called it depth first search. It is kind of a depth first search, I'm not gonna lie. It's a recursive backtracking solution. But yeah, well, anyways, that is all from me. Yeah, let me get out of here.